KTPI is an initiative, is a collective of young faculty members, PhD students, postdocs, etc., aimed at, developing a culture of research in colleges in Kerala. Okay, we do that by providing opportunities to do research at MSc and postgraduate and graduate level. Then conducting talks, organizing talks, workshops, etc. So this program is actually organized jointly by Department of Physics, Cochin College, and KTPI. So KTPI likes to work in collaboration with colleges in Kerala. So that's how we can bring a change, right? So, and when we come to Cochin College is a very prominent institute in West Kochi, and we are conducting this program. We both, Cochin College and KTPI, is jointly organizing this program. And so I'm extremely glad to let you know that the speaker of today's session, Manosh, is an active member of KTPI. He completed his post-graduation from Maharaja's College. Then he moved to CUSAT to do his PhD, and he's currently a research scholar at Maharaja's College. He's an extremely talented young research scholar and highly motivated too. He has been a most important part in KTPI. He's doing all the tech-related things that is needed for KTPI. So we would like to let you know that Manosh have done. This is not just a webinar. This is actually a hands-on. It's partly a hands-on session also. And Manosh have done it already at many places. So I think this session will be an extremely useful one, and we are extremely glad to get Manosh as our speaker today. So before Manosh takes on with this session, let me invite our HOD, HOD of Cochin College, Department of Physics, Cochin College, and Dr. Anita Philip to say a few words. Thank you.
Thank you, Jose.
Yes, Miss, we can.
Good morning, all. I am very happy that Department of Physics of the Cochin College is joining hands with KTPI in organizing today's seminar on LaTeX for scientific writing. We know that the educational sector is witnessing drastic changes nowadays. Today, research is a part of collegiate education, and project work is included in both postgraduate and graduate curriculum. And of course, paper publication is an essential part of research. And nowadays, research and paper publication is a criterion for career advancement also. LaTeX is a very useful tool in preparing reports and papers for scientific journals. Some of you may be being introduced to LaTeX for the first time. Manosh is a highly motivated research scholar from CUSAT who has given talks on LaTeX at different places. Thank you, Manosh, for joining us. And I believe this 1 hour of his talk will turn out to be an extremely useful one for all of you. In Cochin College, we have graduate, postgraduate, and research level students in science stream as well as commerce stream. So, apart from our students, those who are joining together for this talk also will be beneficial after this talk. Have a nice time.
Manosh, can you join now? Can you press? Manosh is facing some problem. Let's wait for some 1 or 2 minutes.
Hello, can you hear me now? Okay, probably that was my headphone. So you can see me, right? Okay, so if you have any concerns or questions, you can drop that in the chat box. And if I hope you can hear me now. There was some issue with my headphone, so can someone say that I'm audible or not?
Yes, we can hear you, Manosh.
Okay, thank you very much. Let me try to share my screen so that. Okay. Okay, so now you can see my screen, right? Okay, so without further delay, let me start the presentation on LaTeX for scientific writing. So we all know that scientific research itself is a very difficult task, and we do that on daily basis as someone who is exploring physics, chemistry, or mathematics, or any stream of science, or not even science. If you are doing research in literature or arts or commerce or social science or economics, research itself is a very difficult task, and you don't want to spend time writing your document in Word and typesetting it and waste your another day or week over that. So, LaTeX is an interesting platform where you can actually write your documents without having any hesitation or any delay in communicating the knowledge that you have once you have drafted the document in some places. So uh, why LaTeX? Because we already know that there are so many platforms like MS Office, MS Word, and the open platforms like LibreOffice. You can write your document everywhere. And why would you want to use LaTeX? Because this is a new software. It's not a new software. We have been using this for decades. But the question is, why switch to LaTeX? So the biggest answer comes with mathematical equations. So if you have a very big, large equation like one you can see on the screen, it will be very difficult for someone who is not so familiar writing equations in Word to write this kind of long equations. So it will be very difficult for me personally, me to write this equation in Word. So LaTeX help you to write such complicated equations and also to create beautiful tables and organize your document very well. So that is the primary reason LaTeX is the preferred choice of writing, at least in the science community. And there are different ways you can get your hands on LaTeX, but I will not go through the slides one by one. I only have 6 slides to share with you. And after that, I will directly jump into show you how to write a LaTeX code in order to create a document. Because whenever you want to study some sort of coding, LaTeX is not high-end coding, but it is at least some set of coding. Whenever you want to learn coding, at least Python, C++, Fortran, or any other programming language, for instance, you don't read a book, you don't go and attend a class, you just start doing it. So that is the primary way of doing coding. So there are two platforms where the LaTeX source codes are deposited. Just note down these names so it will be useful in the future reference. There is only two softwares that you need to remember. One is a repository and other is a user interface. So the first one is the TechLive or MiKTeX. MiKTeX is exclusively for Windows user, I'm not a Windows user, but nevertheless, MiKTeX is for Windows user, and there is TechLive. TechLive is for both, but mostly preferred in the Linux versions. So TechLive and MiKTeX are two sets of repositories where almost every source code written for the LaTeX is stored, and you can download it for free. That's the primary aim, because if you want to use MS Word, you have to purchase Office, right? Or you have to rely on open source softwares. On the other hand, TechLive is 100% free. There are some online platforms which we will see at the end of the talk, which charge you some prices, but that is for the service, not for the tech itself. The tech is a 100% free software, which you can use to write your documents beautifully, especially with math equations, because mathematic equations, you know that one plus or minus can make the whole difference. So you don't want to mess up your equations. You don't want to mess up with the bracket placed in the wrong position. So LaTeX helps you with that. And for the user interface, you have many user interfaces. One is the TeXstudio, which is in the blue color, and the other is the TechMaker. There are several other user interfaces, but I prefer to use TeXstudio because of the inbuilt tools that is already available there. And before we end this presentation part of this talk, which is going to be in like 5 minutes or so, let us dig into the history for one slide. Donald was the one who started creating this typeset software, which is primarily for mathematicians, because you know how mathematicians used to write the documents. When I saw my professor's PhD thesis, he had to keep spaces between the paragraph in order to write the equations, and he wrote the equations by hand. So that was in the early 80s. And when it came to my professor towards the early 90s, he was able to write them on a computer because of the LaTeX software. So Donald was the one who started it, and Leslie was the first one to implement the first manual for LaTeX. So one was a mathematician and Leslie is the computer scientist. So this is all of the introduction that you probably need for LaTeX. And LaTeX is also available in the online platform, and Overleaf is a service provider which will give you an online space where you can construct your document. So what you see here is a source code which starts like a document class article, and you import all the packages and you can write. And on the right hand side, you can see a PDF being generated in a very sophisticated manner. And I will share with you how beautiful you can create these kinds of documents. That is the end of the presentation. Let me just go straight into the actual workshop with this later, because you have to see it on action in order to really learn it, because from the slides you're probably going to learn nothing. Okay, so that's the end. So at this point, do you have any question to ask? If you have, you can drop that in the chat box. I hope I was audible throughout, because I had some audio issue. If no, maybe I can start creating a document for you. Can someone just chat in the box saying that we have no questions or any questions? Okay. So there is an Overleaf, a free software. Thank you. So that was an icebreaker. Asha Sebastian, thank you for the question. So Overleaf is actually not a software that you download and install, but it's an online platform. Thank you for the question. So let me just jump right into doing a project in Overleaf. So in Overleaf, you open a tab and write overleaf.com, and you will be logged into. So I am already logged in. So you'll be asked to log into this platform. If you haven't registered already, you can use any of your personal IDs, Google or whatever IDs that you are using, and just log into Overleaf. So I have been using Overleaf for a very long time. So you can see all sort of projects that I have done in here. It's not like all the projects were I still use it. So in order to get an idea of what all these gadgets are, so you have the account where you can improve your account into the pro version where they will provide services to you so that it will be easy for you to handle your documents. And there are templates available. So in the templates, you can go around and see whether it suits your uh, need. For example, if you want to create a thesis, you can click on thesis, and there are plenty of theses available online. So from various universities, and you can go around and see which document is the best for you. So, for example, this look neat. It's an IIT Kanpur PhD MTech thesis template. So you can click on it, and you can see the PDF, or you can view the source code if you want. So this is a source code, and you can also view the PDF, but that's not necessary. And you can also open it as a template. So once you open it as a template, um, it will take some time. Okay, depends on how fast your internet is running. So if you open it as a template, you can see the source code in the left hand side. You can see all the necessary files on the extreme left. And after a while, you will get a PDF document on the right hand side, depending on how fast your internet is. Seems like mine is quite slow. So this is the Overleaf platform, and it is 100% free. At least the basic version is 100% free. And the interesting thing about Overleaf is that you can share this with someone. So for example, if you and your collaborator is working on a project, and you are the primary author, and you are the first author, and you have written the document, and you're sharing with your co-authors for them to edit, you can actually share it with a read-only option or an edit option and share it, and so that they can also contribute to the document without actually sending an email or all the folders to them. So that is an interesting way to share this project. So that is one thing that you can do with Overleaf. So maybe towards the end of section, you can actually open up your own Overleaf account and try to see whether you are able to create a document or not. So before we actually go into Overleaf, let us actually construct a document on the offline set. So the things that you would need is TechLive. So TechLive is this. So you just Google about TechLive, and you will get this software. And all you need is how to install TechLive. You don't need to read anything about TechLive, what it is and how it is useful and what is the technical details. You just need to install it. So for Windows users, I don't prefer TechLive. I prefer MiKTeX. That is a different repository. So for Linux users, you can install TechLive with one single command, and that you can find over here. So all you need to do is install TechLive, sudo apt install TechLive. That is the simple command that you need to install TechLive on your system. So once you are done, it will take some time depending upon how much faster your internet is, and also on whether you need the full TechLive package or not. So all you need to know, TechLive install in Linux. So you just Google that, and you will get a very simple command to install TechLive on your system. And all you need to do is just one command. First, you need to update the system repository if you are not updated, and then you sudo apt install TechLive full, and -y is a yes command for the installation. So if you want a smaller version, which means the basics are there but not the advanced packages, and that will be TechLive, just TechLive. And TechLive full contains all the packages available in the TechLive repository, so that it will take some time. It is around 5 GBs of data, so you need a very big data package to install TechLive full. But for the TechLive version, the basic version, you just need only 260 MB of space. So that is pretty convenient. So this is the command that you need to install TechLive full on Linux. So I will drop that in the chat box if you want to use. So there is a question about Mac users. I think TechLive work for Mac as well. Because TechLive is for Linux, Windows, and Mac. It is not exclusively for Linux users. I haven't used Mac, so I don't know whether this particular command is useful, but Mac also has a terminal interface where you can install packages like that. I'm sorry, I will look into that, and by the end of the talk, maybe I can help with the Mac people, but I'm sorry, I'm not a Mac user. So this is the only command that you need to install TechLive full. So what do you mean by repository? Repository is where you keep all your stuff. Okay, for example, your bank is your repository for your money. So for example, I have created a TechLive class for a one particular kind of article, and someone else is also creating the same. Someone is creating a TechLive template for books. Maybe someone is for doing it for presentations. All these things are collected together and kept somewhere in the internet. So it's somewhere, and that is usually called as a repository. And TechLive Full is such a source code where all these repositories are organized in a systematic way. So once you download the TechLive, which is the standard source codes that you need, that is there in your system. So when you use an interface like TeXstudio can go into TechLive and look for these codes and make it available for you. So an interesting feature about Windows user is that if you install MiKTeX, so MiKTeX is the version for Windows user. So you just Google about MiKTeX, MiKTeX. So MiKTeX is primarily for Windows user. I don't know whether anyone is using MiKTeX for Linux or Mac, but I think it works for all, but primarily for Windows user. So MiKTeX is also interesting platform, but the thing is that you don't get the whole package in one click. MiKTeX usually gives it's one by one, so all you need to do is click on downloads. Yes, it's available for Mac, Linux, and all sort of users. So the interesting part is very small, 132 MB only file. That is the file size. So once you download it, you know the usual step of installing a Windows exe file. So this is an exe file, which is an executable file. So once you download it, you can right click and run it as administrator. Then will pop-up window will ask whether you want to install it or not, and then you click on yes, and then you can, it's the usual ticking procedures that goes on. And once you installed it, you can then install the interface. So the first thing that you need to do is either install MiKTeX, which is for Windows user, or a TechLive, which is for Linux users. Sorry, for the Mac users, I am not familiar with Mac, but maybe I can Google it. Mac TechLive install. All you need to do is Google how to do these things. So probably they will give you the solutions for this. So Mac is basically a Unix system, so you can have the codes all here. So it's available, or you can go for videos where they are showing you how to install these software. So for Linux user, you just need to open the terminal, which is Ctrl-Alt-T. So a terminal will pop up like this, and then you can copy paste this and the other code, sudo apt install TechLive full. I'm not going to do that because I have already installed it. So that is the primary thing. The second thing that you need after TechLive or MiKTeX is for Windows user. So I already told you it's only 132 MB of file size, while the TechLive is like GBs of file size. So why MiKTeX is small? Because MiKTeX does not give you the full package. So whenever you are compiling your file in your TeXstudio or any other interfaces, you will encounter that, okay, this package is missing. Do you want to install that? So MiKTeX gives you that provision to install all these package on the go. So you don't have everything at once, but if you need it, it will download it for you and install it for you. So that means you probably need internet at least on the first few days of using MiKTeX, because 132 MB of file size is not enough data or the source codes. So that is one good side and bad side for MiKTeX. But on the other hand, TechLive full is your complete package. You probably will not need an updated version. But as you go along with every update, you will get more and more additional package to TechLive. So, and usually the Ubuntu or the Linux user already have TechLive pre-installed, but that is the basic version. But you have to install TechLive full to get the full-fledged use of TeXstudio. Okay. So we don't need any repository for doing Overleaf. Okay, so Overleaf is like an online platform. Imagine it like a Facebook account. Okay, you open your Facebook account and you go through your profile, and you can do whatever you want in your profile, or a Telegram account where there is self messages, or you can message anyone. See this as something similar, where you have an account and you can create your own documents there. So that is the primary purpose of Overleaf. Overleaf was initially Write LaTeX, and then Overleaf took over this platform. So that's it. So once you install TechLive and or MiKTeX, then you have to install a user interface, because we don't want to write it on the terminal, because most of the programming language, they write it on the terminal and they can compare it on the terminal and you will get the document. That is also true for tech users. You can do that, but no one wants to use that. So one of the most best interface is TeXstudio. So TeXstudio is the best because they give you a lot of accessories in it. So TeXstudio, you just open TeXstudio and then you can click on downloads, and you have all these versions available for Mac is there. Then for the Linux users and the Windows users, Linux is the biggest one because probably there are 100 plethora of variety of Linux, including Fedora, Ubuntu, Mint, Dept, and so on and so forth. For the Windows, you just click on the installer that you want, depending upon your system. For example, it's Windows 10, 64-bit, and then you can download this one, and it will give you an exe file, and you can just right click on the exe file and run it as an administrator. You can do that. For the Linux user, you don't have to go through this download things. Just Google TeXstudio install Ubuntu. Then it will just give you the answer for that, and that answer would be just sudo apt install TeXstudio. So first you have to install TechLive full, and after that you can install the TeXstudio. So the TeXstudio install is this: sudo apt get install TeXstudio. TeXstudio is also the platform that we'll be using right now. There are other interfaces. So it is a variety of interfaces are available. So the other one is TechMaker. TechMaker is something that is sometime pre-installed in your Linux system. So my system already has TechMaker and TeXstudio, but I don't prefer using TechMaker because it looks somewhat clumsy to me. So the same things goes with a TechMaker. You can also download the versions and install it, or in the Linux or whatever OS that you are using. So you have to do it in this order. First, you have to install the repository and then the interface, not the other way around. If you are doing it the other way around, if you install TeXstudio before the TechLive, then you have to tell TeXstudio where the hell is TechLive, which is something that you have to go to the configuration and let it know where the TechLive is installed. But on the other hand, if you install TechLive first and then the TeXstudio, they will search it for you and make your life a bit more easier. So that is the way I would do it. So if you are a Linux user, do this TechLive first. If you are a Windows user, you can install the MiKTeX. If you are a Linux user and you want to use MiKTeX, you can do that. But I do not recommend it. For the Mac user, I would also recommend the TechLive, not the MiKTeX. But it depends on your disk space and your internet speed and everything. But for the interface, I would definitely recommend TeXstudio. It's the best one. I think I'm in love with TeXstudio for some reason. Okay, I will show you how to write a document first. So this is the softwares that you need: TechLive, MiKTeX, TechLive or MiKTeX, then TeXstudio or TechMaker. So let us ignore TechMaker and MiKTeX for a while. And this is what you need. So any questions? How will you choose different templates for different academic journal, Haritha? Okay, I will let you know that. Depends on where you want to submit your article. For example, if you want to submit your article in Physical Review, so Physical Review D is the journal that I always read because I'm working in cosmology. So for others, click on that and they will give you the styles and everything that you need. So it depends on the genre. So you can find these in Overleaf as well. For example, Overleaf, go to overleaf.com. I'm already in it. So go to the templates and then you can look for, where is it? Academic journals. So if your academic journal is gracious enough to put a template in the Overleaf, you will automatically find it. Otherwise, you have to search in the website. For example, this is Optic Publishing. I don't know. There are several things available here. For example, you can look for here RevTech. RevTech is the package usually used by the physical review team. So you click on that and you will get the template for the articles that you want to submit. For example, this is a physical review template. This is also a physical review template. You click on that, you open as template, and you're ready to write your first article on Overleaf. So that's all it takes. Okay, you don't have to wait anytime. You just need to go here and whatever collaboration you're in, your first name, your title, manuscript, everything you can just write here and it will compile over here. Depends on the speed of internet because Overleaf kind of consumes a lot of internet. So that is a bad side of it. But if you don't have a very good laptop to run your software, you can rely on the Overleaf platform. Okay, so any other questions that up to this point? Any confusions? So TechLive is the main source code that you need. Consider this as your storeroom where you store your food items and all. And TeXstudio is your kitchen where you cook your food. Okay, you don't necessarily store your rice and all sort of things in the kitchen itself. You probably keep it in the shelf, and the shelf is the TechLive, and you have to keep it stocked. Okay, you don't have to rush to your nearby store when you're going to prepare a meal. So TeXstudio is your studio where you do the shooting, or the kitchen where you do the cooking, and TechLive is your storeroom where you keep all your stuff necessary. And Overleaf, you can think about it as a restaurant. You don't necessarily own it, but you can go and eat. So that is the team behind Overleaf and the installed versions. Okay. Can we download the templates from Overleaf and work on repositories? Or okay, so you can actually download this things. For example, here you have the menu and you can download the source code completely. Sorry for the noise. I'm at home and there is noise around me, so I can't do anything about it. So here is the source code. So you can click on the source code. It will pop up like you can save it, and you can save it in the desktop, create a folder, MiKTeX, or whatever you want to call it, and you can save it there. And you have your tech codes all in there. So that is something that you can do. You can do it in Overleaf once, and once you're done in the Overleaf, you can just download and share it if that is how you want to share it. Interesting thing about TechLive is you can submit to the journal right away from Overleaf. That is one thing that you can do. For example, if you want to submit your article to the archive, or if you have an archive ID, you can submit your paper directly as a PDF or the zip file. Everything you can do, and just by clicking to submit to archive, then you'll be directed to the archive login page where you have to log in and all. But this is possible. So Overleaf is a one-way go if you have a limited system where you don't get enough space to install all the software. But at the other hand, it needs internet to work. So it is kind of difficult. It's a yin and yang situation where you have to choose between whether you want to go offline or online. Okay, so let me try to show you the TechLive that I have. So I have this TeXstudio installed. I also have this TechMaker. So you can see my screen, right? So the TechMaker is there, but I prefer to write in TeXstudio. So TeXstudio, if you open it, you can see the slide that I created in TeXstudio, but that is not the important thing. So before you begin your project or before you start writing your document, the first thing that you should do is to create a folder for it. Okay. let me delete that. Create a folder. It's like my article. So the reason why I asked you to create the folder first is because you have to keep all your necessary images and the class files and all the source codes in there, so that you don't want to write the whole path while you're actually creating this document. So for example, in TeXstudio, let me give you an overview of what TeXstudio will look like. So you have files, you can create a new document from template, or you can open the recent one. These are the ones that I have been working for the past couple of weeks. And you can save your documents, the basic stuff that you will see on the file menu. Then in the edit menu, you can, redo, undo the basic stuff. Identify is the word you can comment on, just controls are there. Then there's a couple of tools where you can build and compile clear auxiliary files. I will get to that point. This is one of the important things. And then there is LaTeX, which is essentially the environment that you are working on. For example, you don't remember how to install or how to create a title, it is there. But once you get the hang of it, you will be able to do it on your own. And for the math and the wizards are some like tabular. If you want to create a table, you can do that. And the bibliography is the most important part of the tech because it helps you manage your bibliography. And there are a few other options, and you can configure your TeXstudio if you want, but I will keep it as such. Okay, so this is the TeXstudio, and you have a couple of windows here. For example, if you want to look for a particular kind of symbol, I don't know what the symbol is called, but you can get that symbol right away in Tech. Okay, so let me start an example document for you. Before that, there is one question. Hi, for Windows user, TeXstudio is the one you. Yes, TeXstudio is an interface. It works for Linux, it works for Windows, it works for Mac, it works for any kind of OS. It's an interface. Okay, it's a software where you can write your document. So TeXstudio works for every OS. As far as I know, maybe there is one OS in the world which does not support TeXstudio, but I don't know about it. So probably nobody ever know about it. So TeXstudio works for everything. Okay, so let me go here, and this is my folder. Currently, my folder is empty. I want to show you this empty folder because once you start doing Tech Live, Tech, you will see other files being created in here, which is completely fine. Okay, so in the TeXstudio, you open with the new from template rather than a new. A new will give you just a blank page and you don't know what to do with it. So after a while, maybe 2-3 times of using TeXstudio or the tech environment, you will start with a new one like this. But for the time being, let us start with a template. So a template is a pre-designed one for you. So you can select articles or the Beamer. Beamer is the presentation kind of document, and then you can think about making a book or letter or CV or report, whatever you want to do. Okay, so there are plenty of options, but let us begin with the article. So you click on article and you click OK, and it asks you to create a folder. Do you want to do you wish to use this folder anyway? Then you click on no, because you know that you want to create everything inside this folder. So this is my article and you want to create it there. So what you do is create. You can either select a template on the article and click. You can go for your folder. So I created it in the desktop and my article, and you can click OK and OK. So this is article template and it is saved in home Manosh team. That's my name, desktop, my article template. So now if you look at the folder, you have one piece of file which is template_article.tech. So even if you just save it and close it, nothing happens. I closed the TeXstudio right now, but in the folder I have just one piece of file which says like this. Maybe if you want, you can rename it. You can call it main or whatever name that you want to call it, but usually people call it main because that is the main tech file. Right now it is just one file in my folder, and I open it in the TeXstudio. So this is how it looks. So it start. So let us forget about everything else. Just start on the first line. So it's a document class. So tech is a typeset software, and whatever you do with tech, you create documents with it. So then there is a blank square bracket there, and there you can write 12 pt or whatever font size that you want, and A4 paper. If you want to write a document which is an A4 paper, if you want A3, you can go for A3 paper, etc. But for the time being, I'm going to keep it blank. And then there is this word article. If you misspell it, it will give you an underline for that, because that kind of file is not available. But for example, if you remove this article and write report in it, it will give you a clear one, because there is a class called a report. And if you can think about writing a book, there is that. But for the time being, I will just go with the article. And then the opening. Then the main thing is begin document and end document. So the key feature of most programming language, it has a start and an end. So it starts with some kind of queue, and it will end with another kind of queue. So here, begin document is the beginning of the document, and end document is the end of the document. And everything that you want to see on the PDF goes inside here. Okay, except for the title and author. You can also bring these guys into the begin document section, but for the time being, I'm going to keep it there. So for the title, I'm going to write my article and my name. Okay, so once you've done that, you have to use this one, make title. So this is why we can write the title and author outside begin document. So for example, you can write that inside the begin document, and then you don't have to make title because it will appear. But if that is not the case, you can call the make title command, and that will create you something. So let me just grab my window and get some article to write. So since I work in cosmology, I need some documents like this. So I'm just going to copy a few lines just to copy paste things, because I don't have time to, type an actual document there. So it's just to, mimic some things. So in the abstract, I'm going to paste this there. And I hope this will work. And let me remove the section command right now. So this is the abstract. So begin abstract, end abstract. So it's a starting queue, and this is the ending queue, and in between you can write your document. And you press this green button, or you can press this build and view, or just the compile. If you compile it, you have to build it again. So you just compile and build together. You click on that, and voila, you have your first article ready. Okay, so this is your document. You can view in the external viewer. So this is the PDF that I just created. So in just one click, I haven't set anything in it. I didn't ask the abstract to come in the center. I didn't ask for the date, but it just appeared here, and it is, the paragraphs are justified. So everything is in place. And how did it happen? I didn't do anything that by myself. It all happened automatically because of the software that we are using. So this is how things work in LaTeX. So right now it is just a blank document with a page number, and so many spaces are being neglected, but we want to improvise. Before we go ahead and improvise a document, let's see our folder, because we started with an empty folder with just one main.tex file. Right now it has a gz file and a log file and an aux file, along with the PDF that you just created. And the PDF will have the name of this main file that you started with. If it is main.tex, your PDF will be named as main.pdf. Your text is like, first file.tex, your PDF will be called as first file. So whatever name you give for this one will be the name of the PDF, and that PDF will just appear as such. You don't have to do anything. So along with that, you will create some auxiliary files which you don't want to delete. Even if you delete it, that's okay. That is completely okay, because you can just run it again, and once it is done, it will appear back. So these are the auxiliary files and log files which they create in order to keep track of the document that you're editing. So this is what is happening behind, but we don't bother about it. We never open it. It's just one and the last time I'm going to open such files. So that is the end of it. So that is how you create an article. So even if you close everything except for the Google Meet, you can open the folder, you have everything, you can click on the main.tech and you're back on editing. Okay, any questions up to now? So that is how you create the basic article. Now we will move on to modifying this article so that you can include things like pictures and all sort of things. And remember, we started with the aim of writing a math equation. So like every programming language, for example, in Python, you will import your what do you call sources, right? If you want to use NumPy, you will import NumPy. If you want to use SymPy, you will import SymPy. SciPy, you will import SciPy. If you want to plot something, you will import the Matplotlib, so on and so forth. For the same goes with this programming language where you have to use the package. So it's use package, and the good thing about TeXstudio is that give you a prompt where you can select what you are writing. So it's use package. And AMS Math is the repository where all the math symbols are easily available. And then there is use package and that graphics. So it's graphics with an X at the end. So you can include the images if you want. And then there is use package hyper rough. So you can hyper rough things. And then there is use package. I don't know, whatever package that you want to call, for example, bracket. So bracket is an interesting package for people who work in quantum mechanics because you have this bracket notation, which is very difficult to write otherwise. So this will help you with that. So just because you added this package, nothing is going to happen to your article. It looks the same. But for if you want to save some spaces, for example, right now from the left and the right and the top and the bottom, plenty of space is being misused. So you want to save the paper as well as the size of your PDF. So you go for use package geometry, and you enter it and you define the geometry of the system. From the left, I want to skip like 2 centimeters, and from the right, I want to skip like 2 centimeters, and from the top, I want to skip like 2 centimeters, and from the bottom, I want to skip like 2 centimeters. So if that is a deal, just write that down. This goes before the begin document. This is the one place you just let the system knows it applies to the whole document, not to one page. So everything that before this begin document applies to the entire document. So that is like the prerequisite. So now the article is somewhat modified. So from the top, it skipped all these kind of 2 centimeter margin. So right now you have more real estate to play with. So that is how you start. So once you are done with your abstract, then you can go and start writing your document. So first you start with sections. So section, every first section is always intro, introduction, and you click run it, then you will have this introduction with the number. Okay, so that is the most interesting part. So I'm going to copy this text because I'm too lazy to type something because I am a lazy typer. So I'm going to write 3 paragraphs. So yeah, I just wrote 3 paragraphs, and this is how it's going to look like. Okay, so if you think this 2 centimeter is too much, maybe you can do it to 3 centimeters and 3 centimeters so that it looks a bit neater. So this is your document right now. So introduction goes like that, and if you want, then you can go with the next section. So I'm just going to copy paste these things. So the next section is going to be like, let's call it cosmology. Okay, so the section 2 came with the title cosmology, and the document continued to the next page, and you automatically have your page numbers there. So you don't want to manually input your page number. But if you want to remove the page number, you can manually remove the page number. But for the time being, I'm going to not remove the page numbers because I want the page numbers. So this is how you go. But sometimes you also need subsections. For example, inside the section, you can have additional subsections. You go like subsection and Newton's idea, whatever you want, Newton's idea of the cosmos. if he had an idea. So that is Newton's idea of cosmos. I just wrote subsection here, and it automatically recognized it belongs to section 2, and it automatically gave it a number 2.1. So this is how neat you can do things. So maybe this is Newton's idea. I'm going to copy paste these 2 paragraphs there. So it just keeps on coming up. Okay, so a good thing about it is that it creates you the sections with the number and also the subsection. Can we do better than that? Of course, we can go for subsections. Okay, subsections is kind of like 2.1.1. So you'll have an additional section there. Current, trend, or whatever that you want to do. And you compile it, and then you have this 2.1.1. So here you are automatically doing this stuff. Let's say I want to include a section before Newton's idea. Let's call it before Newton's idea of cosmology. And right now, before Newton's idea of cosmology is 2.1, and Newton's idea of cosmology became 2.2, and the current trend became 2.2.1. So it automatically adjusts where you input your sections. So you don't have to keep track on whether it is 2.1 or 2.2. I don't remember it. The tech does that for you. So like this, you can keep on writing your document. Now, the biggest challenge is to write an equation. Let's write an equation between these 2 paragraphs. So every time you want to write an equation, there are 2 ways. The first way is to begin equation, and you can write a famous equation, F is equal to ma. It's a simple equation, and I just compiled it, and it appears with like that. Remember, in the math environment, the letters will be italics, so F and M are slightly tilted, while the text documents are not, and it automatically gave it an equation number. So if you want to repeat that equation, F is equal to ma, or you want to like kinetic energy is equal to half mv square. Let me write it in the bad way first, mv square. So it gives you the bad kind of thing, but you can make it, you can improvise it. For fractions, you go like slash frac 1 by 2 and mv square. So this is all you need to write. Okay, and that just comes like this. Okay, sometimes this kind of frac environment also work in Word, where you open the equation window and you can type in these commands, but not everything comes like that. For example, if you want to take the square root of this thing, okay, you want to take the half mv square and square root of kinetic energy, what you can do is just write sqrt slash sqrt, begin braces, end braces, and you just write that equation, and it comes in like this. Okay, so every command in the text begins with a slash. So this slash is the most important thing. So after the slash, you can press B, and it will give you the begin environment. So if you want to begin something, you can start doing that. Okay, sometimes this is not enough. You want to write an equation in the line. For example, if you want to write the equation like here, then you don't need to call the begin equation end equation. It will comes with the equation number, but you want to write it in line. So what you do is to call the dollar signs. So these are 2 dollar signs, and in between you can write your math equation. So it's like mc square. So you want to write E is equal to mc square there, and there you have it. So in line you can write it like that. Okay, so that is the way of doing it. For example, if you want to write this equation, you can just copy it there, and you can place that in between the dollar sign, and there you have it. Okay, so that's how you write inline equation between the dollar signs. Okay, so this is how you write the equations and the section. So now probably you can write an article all by yourself. Okay, any questions so far? Beginning of every paragraph are not same. How to rectify? Insert table and graphs. Okay, so you can begin a paragraph in different ways. So the paragraph is not justified in the first one, and then you can have the intention. That is the usual way of writing a document, because the first paragraph is not intended, for the second paragraph there is intention. But if you want to skip a line, for example, in the introduction part, let us skip a line, then you can do, all you have to do is put 2/ and then compile, then you will see that one line is being separated. Okay, so that's how you create spaces between line. But if you want to create additional space, you don't go like this, because if that happens, sometimes there will be errors coming out. Okay, but you can keep on doing that if you want, but that is kind of not necessary and not interesting, but this is how you do it. Okay, now the biggest challenge is to input a figure. So let me go and grab a figure. So since I'm writing something about cosmology, let me get a picture like that. So okay, go to images, whatever picture that you want. Okay, here is a good galaxy image, so I am going to save this image. So how do you save it? You go to the desktop and in your folder, okay, web page is not required, so I'm going to go for something simpler. Okay, view image, same image as, it's a JPEG image, and you can go to the desktop, my article, the folder where you wrote the article, and you can rename the file as just fig1. Okay, that's for simplicity, and you save it. So in your article now you have this figure along with other files that you just created. Okay, so coming back to the tech, in order to include a figure, again like the equation, you have to begin an environment. So begin figure. So once you call the figure, you have to include the figure, so that is include graphics, and this is not necessary, but let me tell you why that will be necessary. And you can go with figure1. It's figure1 .jpg, which is the extension for the file, but you actually don't need to give that extension in calling out the figure if you are very specific about the file. So it comes out like this, but that is not something that you want. It took an entire page and it is not completely visible. So what you want to do is you have to give it a width. Let's call it width, and I just want it to be 5 centimeters. Okay, so that's it. So once you do that, it's ready. But the figure is down here. I wanted it after the first paragraph, but it just automatically appeared at the very bottom. So I want the figure to be here. So I call an extra square bracket there and put h there, which will tell it to come over here. So the figure is right now where I want it to be, but the figure is not centralized. So what you do, you just go ahead and type center, then it will give you centering, and you can use that. Now the figure is at the center. Okay, so right now the figure doesn't have a caption. Okay, the figure doesn't have a number. So what you do is you go ahead and go for caption, my figure, okay, that's it. And it comes with a number, figure1, my figure. Okay, if you want to have a description for the file, so let's say my figure is very small and I want to have a long description of the file, then you can have it like this. Okay, so the figure1 and the description of the figure is there, and you have the figure there. If you want the figure to be slightly bigger, you can go ahead, let's say 8 centimeters, that would be too big, 7 centimeters is fine. So now the figure is slightly bigger. So this is how you can include a figure in your document. So if you want the figure to come at the very bottom, you can click remove the H and put B there, then the figure will come at the very bottom. But you don't want that, you want the figure there. So H is here, so the figure will come out there. Now the interesting aspect of using the tech is not any of this. You can label this figure. So you go like label and you call it, I think this is the galaxy deep sky image. So I'm going to say deep sky. Okay, deep field image of Hubble probably, and I'm gonna save it and run it, and nothing happened. Okay, now comes the most amazing part. I can call this figure here. For example, if I want to cite the figure here, I can just say C figure, that is the usual text, and in the bracket I want to say a ref, and you have to, you can already see that rough deep sky there. So you just click on that and you end the line, and you click here, and it already gives you that figure 1. Okay, whether the figure is figure 2 or figure 3, it doesn't matter. It just tells you that figure, and you can actually click on the figure. Okay, you can actually click on the hyperlink and go to the page where the figure is. Okay, but the figure is already in the first page, so it is not so interesting to do that. So let me grab that and go to the very end of the document and paste this there and just run it, and you can have the figure there, and you click on it and go to the page where the figure is. Okay, so that is an interesting thing to do, and it also works on the PDF. You click on this, so this is the PDF opened in a different platform. You click on the hyperlink and you go to the page where the figure actually is. So that is one way, that is a primary use of this tech. Now the thing is that you can do the same thing for the equations. You can call this equation by a label. You can label it as EQ. I usually put an EQ in front of the label for the equation, which is Newton's law. So that is given there, and this is another equation. Let's call it kinetic energy. So equation KE is enough, or square root of kinetic energy SKE. So that is enough, and I run it. So running it, nothing happens. So let's call the equation somewhere. For example, I want to call this equation here. Okay, in between here. Let's say equation, what equation that I want to put, ref, and it's already have deep sky there, but deep sky is an image. Then there is equation, EQ Newton law. So Newton's law, I clicked on it, and immediately you have the equation number there. So you can click on it and it goes to the equation, F is equal to m. So you can also do the same with the second equation. Let's say equation that and that. So it's equations that and that. So instead of Newton's law, I gave the name as K, right? So square root of kinetic energy. Click on that, it gives you the equation number there. So it tracks you the equation. Let's add another equation above it. So if I copy paste this equation here, you can see that Newton's law became purple in color. That means you have given the same label for something else. Okay, so you have to remove it. So let's give it deep sky. Again, it became purple because you already labeled the figure as deep sky. So you have to give it some other random name. Let's call it my name. I don't know. For some reason, I just gave that name. So that became equation 1, and the previous equation 1 became 2, and the next equation became 3, and automatically these two becomes 2 and 3. So you don't have to go to the document and edit it over and over again. The LaTeX does that for you. So that is the interesting part of using the tech. Now you want to, let's say, write, okay, for another thing that maybe you started writing tech and it became a very long article and you want to go see where the figure is. You can right click here and go to source. So you can immediately go here to the source file of the figure. Okay, so that's how you do it. You can right click and go to source. Then you go to the source of it. You can also have a control F function there, and you can search for something. If you want, advanced options are here, and you can play around with it. Now, another thing is to insert a table. So let us insert a table. So to insert a table, I can use the wizard. Then there is quick tabular and quick typing. So I'm going to click quick tabular, and I'm going to have a couple of, you can add these things by hand, or this is a platform where you can actually get the use of TeXstudio. So this is how the command of the table should be. So this table has 1, 2, 3, 4, 5 columns, and 1, 2, 3, 4, 5, 6 rows. So that is the table, and if I run it, I will get a table like this with nothing in it. Okay, so again, if I want this inside a table environment, I can begin table and I can paste it there, and it will give you a table with a table number, but I want the table to be here again, similar to the figure. So the table came where I want it to be, and I want it to have a caption for that table, and let's copy some text inside that caption. the caption goes like this. And okay, you have the table 1 and like that, but it's not centralized. So what you do for centralizing, you type central, and then you have the table that you want. Let's fill the table with something. It's like number, name, school, age, class. Okay, then it automatically comes up there just like that. Okay, it's like 1, 2, 3, 4, and 5. So you can just keep on filling the table according to your need. And the interesting part is you can write your math equations inside it. For example, I have this equation and I want that equation inside here. So I just grab that equation and let me show you an error. Okay, so far I haven't shown you an error. So this comes like an error. So whenever an error comes in, so there's a main tag, an error coming, error a line in the line 78 and missing dollar. Because I wrote a math equation without a dollar sign, that's the reason. So I just put a dollar signs there and write my math code. Although there is an error, the TeXstudio gives you the result, but in order to remove the error, it is better to remove the error. Now there is no error, process exit normally, and you have your equation inside the table. Okay, so that's how you start with the text. So again, you can label this label this. I usually go like tab 1 or tab whatever name that you want to call it and save it. So this is how you can call. And for example, you can, although the table is at the end, you can call the table at the very beginning. For example, I can call that in the first paragraph. For example, here, C table, usually put a bracket around it for some reason. Rough tab 1, there you have it. So once you run it, you can click on here and you can go to the table. So that is how hyperlinking works. So this is why text is important and text is simple to use. Now let me show you a hack that I usually don't share because this is secret knowledge and you don't want your teachers to know about this knowledge, especially when you are writing a very long equation. Okay, so let's say you found an, let me see if there are any questions. How will we insert an image in between articles? I think I showed you how to include Python program and could we run it. You don't necessarily run a program in TeX. TeX is usually a place where you document things, but you can actually type your Python program in a format that looks very close to Python in TeX. I think I will show you at the end, Gautam. Maybe that is kind of like an advanced question. You can't run a program, but there are things that you can do in TeX. For example, if you want to draw a graph, you don't actually have to draw a graph somewhere in Python and import it as an image. You can actually draw images in TeX using a package called TeX. But it's kind of difficult to do that at the beginning. But once you get a hang of it, it is very easy. But usually people don't do that for some reason because you have already enough time to do the experiments and conduct your research, and then you don't want to spend time coding how to write, how to draw a graph, because you usually draw the graph in Python somewhere and you can import it as an image. But yes, you can draw things and you can use some basic coding. You can actually do that, but usually people don't do that. Okay, now let me show you a trick that I find easier. For example, Einstein equation. Okay, it's a very tedious equation. Einstein field equation. There are so many equations for Einstein. Okay, I misspelled it, sorry. Einstein field equation. So you go to Wikipedia and you have this equation that you want to write. Okay, it's a very simple equation. Yeah, the one with the Christopher symbols. It's kind of complicated, but you want to write this equation anyway into your thesis. Okay, let's say you want to write this equation. Let's me take the biggest equation that we have here. Okay, this one looks tedious enough. So f, and then there is a square bracket at the subscript, and it's a long equation. Now, how do you write this equation? You can write that equation on a paper and then type all this equation into your text. Or what I would do is, if it is already available in Wikipedia, we can inspect the element and you can see the display command here. So we just copy that one. So that is the display from the beginning to the end, and just copy that and come back to my article and go like, there's another environment other than begin equation that is called begin align. The begin align also works with the max equation, and you can paste it there. The display style is not necessarily required because you're already inside a begin align environment, and you click it and you have your equation in your tech. Okay, so this is begin aligned again inside here, which is not required because I'm already using a begin aligned environment, so I can remove that one as well. So and a few other things. Okay, so you have your equation directly from Wikipedia to your article. You don't have to spend time writing the same equation which is already available on internet, because somebody actually wrote that equation for you on this platform. If that is an image, you can't do anything about it, but if it is somewhat like this, you can actually copy the source. All you have to do is right click, inspect element, and in the pop-up window you will click on there. You can see some slash frag, and you double click on that, and then you will be able to copy it, and you can come back to your tech and we can write begin equation, and voila, there you have it. Your equation is there. Display style usually is not required. The reason why you have display style is to paste that inline equation so that it looks the same. So without the display, it looks a bit smaller. So, it became slightly smaller. With the display, it will be slightly bigger. So it just got bigger. So that is the only thing, because in between lines, if you're writing a tedious equation, in between the lines, you have to make it smaller. Or if you want to make it bigger, then you have to use the slash display style. But that is something that you will get the hang of. So this is how you write this equation. Again, let's put this equation back to the top, and let's see whether our equations are properly numbered again. So I put these equations back here. Now our previous equation became 5 and 6, and see the reference automatically updated to 5 and 6. So this is how you write an article. So I think your article is pretty neat right now. So you have your images, you have sections, you have your subsection, you have your subsection, you have your table. What else you need? You probably need a reference list. So for references, you can use the package called as bibliography. So for example, let me go to physical review again, because they are the best to give you references, for example. And this is an article. Let's say you read this article. Okay, let's don't take any editor suggestions, because editors are very cruel. Okay, everything is editor suggestion. Okay, let's say you got this article. Okay, enhance superconductivity in CUS2 monolayer, and you can see the PDF. You read the PDF, you did your research. Now what you want to do is you want to give proper credentials. So export citations. So it comes like an article @article so and so. You copy that, but you don't just paste it there. What you want to do is to create an extra file. So what you do is go to the folder and create a new text file and call it as ref.pip. You can call whatever name you want, but it should have an extension called as Dept. And you open ref.pip. It will be a blank document open in the TeXstudio environment. You paste your article entry over there, which you copied from the website of the journal. So this is the article ID. This is the title of the article, and this is the author list, a huge author list, and this is the journal, the volume issue, blah blah blah. And all you have to do is, for example, if you want to cite this article here, you can actually do that. For that, you need to import two things, that is bibliography style. I am going to call it nature because that is one simple style, and then the bibliography file. So bibliography, and that is simply rough. So you run it and nothing happens because you haven't called the citation. Let's say I want to cite the article here before Newton's ideal. Let's cite this article. So all I want to do is type cite, and already have this given there. But if you don't do that, just site and you come to the bib file and you copy this ID. You can call this multiple times and you paste it there and you run it. And you will probably get an error because it has a question mark and nothing came. You run it again and you still don't have it. Okay. So the problem here is if that is a problem that we encounter. So bibliography LaTeX. Whenever you encounter a problem, you go like this, and you have bibliography management here, and you can call it like begin bibliography and so, or what you can do in the MiKTeX version. So this is how it should be done. Reference style plain. Maybe it was an error with this plain thing. So maybe the nature is not included. I can call it as plain, and let's see. And voila. So nature is not available in the system. So a reference one, all the names are there because physical review gave all the list of names. And you have this article name, enhanced superconductivity, and so the article journal and the ID and the year and the month, everything. And you can see over here, it is properly cited. So if you want to cite another article, let's go to physical review again and see some other articles. Let's dynamics of magnetics chromions, whatever that is. And I want to cite this one. Okay, let's copy the bib item. So this is how a bib item looks like. Some people go for the RIS way because Nature journal kind of make it available in the RIS format, but you want to make it available in the MiKTeX format. You copy that, you come to your bib file, you paste it there, and you can copy this ID and cite it wherever you want to cite. For example, I want to cite it here. Let's call it cite and paste and run. And automatically that became 2 and this became 1, and you have your article there. So sometimes you want to clean your auxiliary files. You clean it, okay, and then you run it again. Okay, so that's how you probably want to keep citing your articles in any way. Okay, you can. There are other than that, there are plenty of options. IEEETR, I think that auto works. Clean auxiliary files, okay, and you run it. So now you can see the first citation goes to the first one and the second citation goes to the second one, and you have the articles rearranged. Okay, superconductivity is the first one I cited, dynamics of magnetics chromions, the second one I cited. So this is one way you can keep on citing, and your references are also included. So that makes your life much more easier. Okay, any questions? How to see the PDF after creating text in TeXstudio? Okay, so now you have the PDF on the right hand side of the software. What you do is go to your folder, and inside the folder you have a main.pdf file. That is your PDF file. So there you have it, your PDF article, all set for you to share. So you have your reference. You didn't type reference there. It automatically recognizes the bibliography is the reference. If you want to call it a bibliography, you have to rename this, but that's not necessary. This is a reference. And everything is there. You can click on the table 1, it goes to the table 1, and you can click on the citation number. Let me zoom that a bit. Okay, so here is like the citation. You can click on citation, it goes to the citation number. Okay, if you want to click on 2, it goes to 2. Both are on the same page. There is nothing to do more. So it's all hyperlinked. So that is the easiest thing about creating an article in tech. Okay, so right now, so far this is an article. Now I want to create something called as my report. So report will have something extra. Okay, if I'm taking too much of your time, please let me know, because it kind of takes too much of time. But I'm going to copy this main file and the figure back to my report, because most of the things are same except for a few commands. Okay, so this is the main text for the article. Now I want to close this and the reference. and the TeXstudio is also closed. So I'll go to here and also take this ref.pip because I don't want to waste time writing the same thing over and over again. So here, what you do is open this one, and instead of article, you want the report. Okay. And just like that, after just writing report, you can click run and it will give you a report. The report has a first page, an abstract in a separate page, and right now the sections are like 0.1. Why is that? Because in an article there is no chapter, but in reports there are chapters. So you can write slash chapter and it's like let's say relativity. Okay, relativity and cosmology. Okay, if that is your chapter, you can write that and voila. So in report you have chapters. So your thesis or your dissertation is essentially a report. It begins with a chapter, not with a section. An article starts with a section. It doesn't have a chapter. The article might have parts, but it doesn't have a chapter. But the report has chapter, and see the chapter 1, 1.1, and 1.2, 1.2.1, and subsection, and everything goes like that. But subsection doesn't come with a number because you already have so many things. Now also the bibliography. In reports you have the bibliography name and you have the bibliography already well settled, because I haven't changed anything in this text file except for the fact that I just changed the article into report. Now for the articles you also need a table of contents. So after main title, just write table of contents / table of contents and save it and run it. Okay, now you have a content line. So automatically it gives you a content with the chapter name, with the section name, the subsection name, and the number, and it is also hyperlinked. So if you click on it, you go to the chapter. Okay, you click on the subsection, you go to that subsection. So it does that for you. Okay, similar to table of contents, you can also write list of figures. Okay, there is only one figure, but there is a figure, and then there is a list of tables because I do have one table in this, and I save it and run it. Okay, so right now sometimes you have to run it twice because you know, they have to create these auxiliary files and so, but if you don't get it in one run, you have to just do it once more. So you have the list of figure. So this is the figure 1. So that there it is. And you also have a list of tables, and you click on the table and you go to the table. Okay, there it is. So, and you can go to the my report folder, and now the report folder is quite big. I only started with MiKTeX, roughpig, and one figure file, but right now I have so many other files. You don't have to delete any of this, you should not. And the main file looks like this. Okay, so fit page, this is the front page. Your report start with the front page where your title is there, your name is there, and the date if you want, and then goes the content, and then the list of figures, the tables, and the abstract of your report, and your chapter 1. Okay, and your bibliography at the end. Okay, if you want to add additional chapters, all you have to do is repeat the same process. For example, I want to have another chapter where I do the data analysis. So after this, I can paste it here, and let's say I'm doing some data analysis. So data, and I run it, and that comes as chapter number 2, data. I don't know whether that chapter is useful, but right now, if I compare it again and go to the PDF, I have this chapter there, and interestingly, in the table of contents, you have the second chapter. And sometimes it is very awkward to see this red boxes around it. Because when you take the printout, these red boxes will disappear, that's for sure. But in the PDF version, you can see this red boxes in order to make you know that, or make you aware that this is hyperlink. So you can remove that hyperlinks. Just whenever you have a problem, you just Google it. So hyperlink remove color. LaTeX. Okay, so remove ugly borders around clickable course, blah blah blah. And what we have to do is this hide links command in a box above it. So that is pretty much neat. Okay, you can also change if you want hyper setup like this. or hide links is more than enough. Okay, so I'm going to use this one. I'm going to copy that and I'm going to paste that in the preamble, which is above the document. I'm going to run it. And let's see whether the hyperlinks have gone. Yes, I don't have the ugly borders now, but it's still clickable. You can still go there. So if you go here and into the main document, you don't see those red boxes again. This is the content up close. So the content, it automatically gives you the title, the first chapter, the second chapter, and the chapter numbers and all the sections and subsections. You can still click it and you can still go there. And if you want to see the figures and it's like the list of figures, it is still clickable. Again, can go to the figure page. So the idea is that you just remove the hyperlinks. Okay, see table 1.1. It is clickable, but you can't see whether there is a red box or not, because there is no red box. And you go to the table and see figure 1.1, you go to the figure. Okay, it usually go to this section part. It doesn't show you the figure on the first place. For let me do that again. For example, see figure 1.1, it go to the part where you can read the figure caption at the top. Okay, because the caption is what we hyperlinked. So then you have to do a bit of scrolling to see the figure. So that's how it is done. And then, for example, the equations. So I wrote the equations here. So equation 1.5, it is still hyperlinked. So here, back then it was equation 1, 2, 3, etc. Now the equation is like 1.5 because it belongs to the first chapter and the fifth equation. You click on that and you got the first equation, F is equal to ma, with equation number 1.5. Let's say you don't want to have an equation number for that. For example, this is a repeated equation, and this equation, let's remove this 1.3 number. Okay, so go to the source. All I have to do is put a star at the end of the equation. Okay, and compile it, and that number is gone. 1.3 is gone, but the next equation got the number 1.3, and this became 1.4, and here the reference is like 1.4 and 1.5 rather than 1.5 and 1.6. It automatically tracks all these things. Okay, let's say you want to add an additional chapter before this first chapter. Okay, so let's say chapter introduction. Okay, then you run it, and then you have an additional chapter up front, and your relative and cosmology became chapter number 2, and your equations are numbered like 2.1, 2.2, 2.3. It automatically tracks that for you, and you go to the content page and you have this chapter already well settled for you. So this is why you want to use tech. So I think I have motivated enough you to use tech, because it creates beautiful reports at the end of the day. So we have this fit page. I'm going to view it in dual mode so that you can appreciate how it looks. So it starts with the first article, then the content page and list of figures, list of tables in the abstract, your chapter 1, chapter 2, and your chapter 3, and your bibliography. This is a well-written document. You don't have to do anything more. You just have to insert all your content inside this so that you can have a beautiful report at the end of the day without doing any alignment things that you usually do with the Word. So near my institution, CUSAT, there is this center where they typeset the document for you. But for that, you have to pay like 100 rupees per hour, or like 100 rupees per 2 or 3 pages, or 1 page maybe. So if you're writing a thesis of like, let's say 200 pages, you have to give a huge amount of money just to typeset. But you can do that for free in your system. This is actually a skill. You can actually get placement because of you know the tech. Because there are companies, publishing institutions or publishing companies where they hire people who know tech because they want to create beautiful books. So I have a friend in Trivandrum who does that. So this is actually a skill that you want to learn if you are doing science, especially with long lengthy equations like this, because you really can't write this equation very easily in Word. So that is the reason why you want to choose tech over anything else. So how to write an equation? When you have a problem, you write the equation according to how you read the equation. For example, if you want to write begin equation and say alpha equal to beta, so write alpha with a slash, alpha, alpha equals slash beta, and you're all set. You have alpha equal to beta. Then alpha beta into square root. So you have to write square root of 1 by 2. So 1 by 2. So now there is an error because I have an extra bracket here. Just remove that extra bracket and okay. So there was extra. Whenever there is an extra bracket, it will give you an error. So make sure you don't put additional brackets. So sqrt square root of fraction 1 by 2. Okay. So you type the equation according to how you read the equation. So whenever you write the equation, you can also read the equation, right? So however you read it, you can just keep on typing like that and your equation will pop up beautifully. And you can put brackets. So let me show you one thing. So if you put bracket around it, like a small brackets, it will come like this ugly brackets. You don't want to do that. So what you do is, you copy the things that you want in your inside your bracket and you say left and right bracket and you paste it inside that, and what you have is big brackets for you, and you can, if you want to raise to that raise to 4, and you have it there. And if you want to write like trigonometric function, you can write like the sine of theta. Okay, it comes like this. Now why did I choose slash sign instead of sign? Because if I write sign, it will also come, but as you know, the normal text inside an equation comes in an italics way, which is something that you don't want. So sometimes some functions are there. So if it's like log, you can have it. But if you have some complicated function, maybe that is not in the text, so then you can go like slash text and sign. If that is not already predefined in the text environment, then you can still write it. So inside of the equation, if you want the text to come as the text, you can write that in the text command. So that is how you create a beautiful report. For me, this is a beautiful report. Okay, maybe you don't like it, but I think if you are really into typesets, you will definitely love using LaTeX. Okay, so with the Overleaf, you can just import the same things inside here and do the same.
Manosh?
Okay. Yes, I think we are running out of time. So if you have any questions, we can take some. Hello?
Hello?
Yes.
You're taking questions now?
Yeah, I think I showed you how to write an article and a report. That is pretty much it. And if you want, I can show you how to create a PPT also, if you have time. I think we are running out of time, right?
You can take 5 more minutes. You can
Okay. Okay, then let me show you the PPT that I made for this presentation. So in the documents, I have this KTPI and the guide. Oh, sorry. Talk. So this is the PPT that I made. So I have all these images which I included in the PPT, and this is the main PDF that I created with the text. So in order to do that, all you have to do is, instead of anything else, you write Beamer. So Beamer is where you can create PPTs. So you compile that and you will get your PPT ready. And in PPTs, all pages are like a frame. So you go like begin frame and write whatever you want, and it will come as an extra frame. So there you have it. So begin frame, end frame at the very end, and whatever content you want to put that, you can inbuild there. For example, in this page, I just have only one figure. So begin frame, end frame, and begin center, end center, and in between include graphics. I haven't used begin figure here because I didn't want to use a caption. But if you want to use a caption, then you can call it in the figure environment. Otherwise, you can just call the figure and it will pop up. Okay, and here I have used 2 mini pages for Donald and Leslie. So it's begin frame, end frame, and in that frame you started a mini page and end page, and in that page you started a small begin center and end center, and you included the figure decay for Donald. And here it's another mini page for Leslie. Okay, so that's how you keep on adding different things. And here you have the title, which I called the LaTeX for scientific writing, and I can color this one. So this LaTeX is coming from this particular course /LaTeX, and you can use X color, or it automatically comes with a default one. So text color and red blue, that is the combination that I use for this particular color, and you can have that. For example, coming back to your PDF, and for example, if you want this title to be in a particular color, you can copy that and you go like text color, but it is not giving me the prompt, which means I haven't called the package here. So what I want is X color. So use package X color, and now you will be able to color your text. So it's like slash text color, there you have it, and it's like red. Let me give you the basic one, and there you have it. So now the title is in red color. Now if you want a combo of color, if you are a color expert and you want to change the color according to your will, so it's like 80% red and 20% blue. So what will that look like? And it will give you that color combo. It will slightly look like that. So if it is the other way and you want like 20% red and 80% blue, you just change it. So that's how you can change your color. If you want to make something bold, you copy whatever you want to make it bold and shift Control B or text BF, and it will make it bold in font. And if you want to emphasize or make it italics, select that one and Control I, and that will give you text it, and that will give you an italics one. So like that, you can explore a tech online. Just type whatever you want to search for it, and you will have, for example, text bold in LaTeX. It will just give you the command that I just used, text BF. Okay, that is bold font. So use text BF command, or you can just click on the document that you want. For example, both effect, and I want to just Control B, the way how you do that in Microsoft Word, and you have that bold effect all that. So that's it. And if you have any question, I will make this basic text available on the KTPI web page in a few days time. Maybe you can go there and download the one from the GitHub. So if you are interested, otherwise you can just Google about these things and you can learn by yourself. But I think this is quite enough to get you started. So you started with an article, then you went for a report, and finally you have a presentation, which is essentially what you do for your things. So the article, then the author, and inside the author I wrote the entire thing, and then this date /date and /today, and it will give you today's date. And then you keep on including your images. For example, if I want to have a title for this one, let's say that is figure, and I want to give it a title, Overleaf. I can just add a title, and it will come up as a title of the frame with a different color and a different font size, and so on and so forth. So that is one way of doing it. And you can also have equations here. So begin equation, end equation. So
Manosh,
yes,
time is running up.
yes. So let me end this like this. So you can also write equation in the Beamer with the equation numbers. So I think that is pretty much it, and I think I covered everything I can in this time. So let me stop presenting, and if you have any questions, I'll be happy to answer, but otherwise you can just Google about it, or yeah, you can Google about it. That's it. And sorry if I took more of your time, because you can't just learn tech in a day. Rome wasn't built in a day. Likewise, tech was not learned in one day. So if you have any questions, you can ask, and you can reach the KTPI anytime you want. So we are always here to help you. So, and thank you for giving me this chance. And also thanks to Cochin College for...
Thank you, Manosh. Thank you for this interesting and wonderful talk. I think it was really useful. And it was really useful. And I believe that it will be useful to many people who are listening this, especially the first year and first year MSc students and third year BSc students. for them it would be really useful because they are going to write their project reports and all. Anyway, that was the targeted audience for us also, right? So I think nobody's. Manosh was taking questions during the talk, so I think there are no more questions are not there, and time is also running. So from audience, can any of you please come up and give him a feedback? Give Manosh a feedback.
Maybe one last question. Kelvin Chakko is asking, sir, will Beamer come in PPT format? No, Beamer will also come in PDF format. There is no PPT here, there is only PDF. You can export that into different formats if you want, but PDF is the default output of the TeXstudio. So no more PPT, only PDF. Okay, thank you.
Nitya Satyan has another question.
Yeah, how to share the report to someone for further editing? Oh, that's a very good question. That's the most important question. In the Overleaf platform, you can, I already showed you the sharing option where you can click and share. But if you are using the offline one, go to the folder. You can zip the folder and share it. Or if it's just a plain text document with only text and equation, you can just share the main.tex. And if the other user also have TeXstudio or everything installed, they can automatically run it and everything will follow. So all you have to share is the source files, which is the main.tex, and the images and the bibliography file, which is the ref.bib. So you can just share that, or you can share the entire folder. But sharing the entire folder comes with extra MBs because PDFs are usually heavier. For example, the presentation PDF is 1.4 KB, but the main text is very small. So, for example, the PDF that I created is something around 1.4 MB, but the text file is only 1.4 KB. So you know the difference, 1,000 times smaller. So you can share the text files, just the text file, or you can zip the entire folder and share it. And remember to keep all the source files in one folder, otherwise you'll be cluttered with all these files here and there on your system. Okay, thank you.
Thank you, Manosh. Here, Alex and Grishma have thanked you. Okay. And
Okay, thank you everyone for having me.
can any of you give him a feedback? Can any of you come online and give a feedback?
സാർ ആദ്യമേ ഞങ്ങളുടെ കൂടെ ഈ ഒരു ലൈവ് സെക്ഷൻ പങ്കുവച്ചതിന് താങ്ക് യു. സാറിൻ്റെ ഡീറ്റെയിൽ നമുക്ക് എല്ലാവർക്കും അറിയാം. സാറിൻ്റെ ക്ലാസ് വെൽ ഡീറ്റെയിൽഡും നല്ല ഡിഫൈൻഡും ആയിരുന്നു. ഓരോ സ്റ്റെപ്പും സാറ് ഡീറ്റെയിൽ ആയിട്ട് എല്ലാവർക്കും പറഞ്ഞു തന്നു. പിന്നെ ഡൗട്ട്സ് ഉണ്ടെങ്കിൽ അത് ക്ലിയർ ഒരു മടിയും കൂടാതെ സാർ അത് ക്ലിയർ ചെയ്തു തന്നു. ഇവിടെ നമ്മുടെ കൂടെ ഉണ്ടായിരുന്ന എല്ലാവരും മെജോറിറ്റി സ്റ്റുഡൻസും അല്ലെങ്കിൽ എല്ലാവരും പ്രോജക്ട്സ് ഭാവിയിൽ പ്രോജക്ട്സുമായിട്ട് ഇൻവോൾവ് ചെയ്തിരിക്കുന്നവരും അല്ലെങ്കിൽ ഇപ്പം തന്നെ പ്രോജക്റ്റുമായിട്ട് ഇൻവോൾവ് ചെയ്തിരിക്കുന്നവരാണ്. അപ്പോൾ എല്ലാവർക്കും അറിയാം ഓരോ ആർട്ടിക്കിൾസിൻ്റെയും റിപ്പോർട്ട്സിൻ്റെയും വാല്യൂസും എന്തൊക്കെയാണെന്നുള്ളത്. സോ എന്തൊരു യൂസ്ഫുൾ ആണ് ഈ ക്ലാസ് എന്ന് എല്ലാവർക്കും അറിയാം. സോ ഇവിടെ പാർട്ടിസിപ്പേറ്റ് എല്ലാവർക്കും ഈ ക്ലാസ് ഭാവിയിൽ ഉപകാരപ്പെടട്ടെ, ഇത് അപ്ലൈ ചെയ്യാൻ പറ്റട്ടെ എന്ന് ഞാൻ പ്രതീക്ഷിക്കുന്നു. വൺസ് അഗെയിൻ താങ്ക് യു സർ ഫോർ എ വണ്ടർഫുൾ ടോക്ക് ആൻഡ് എ വണ്ടർഫുൾ ടൈം. താങ്ക് യു സർ.